Okay, let's move to lecture 3, volume element. Okay, before we did the length element, then the surface area element, and now lastly the volume element. You see, here are the contravariant coordinates. Attention now, they belong to the V vector space. See, all these developments, they are made based on the V vector space, not the dual. We can do the same derivations using the dual because the arc length, surface area, and volume element, they are invariant. They does not depend on the coordinate system. Now, you see this A1, A2, A3 are the basis vectors, belong to the V vector space, okay? This is vector space. Also, the contravariant coordinates. Now, since the definition of the basis vector, the volume element can be expressed by the mixed product as dV is partial R respect Ci dxci dot. Now this is a cross product here over here. Partial R respect to xj, partial R respect to xk. Now, so this over here, this partial R respect to xi, xj, and xk, they are just ai, aj, ak. I just group these three here and write dxi, dxj, dxk. So that's it. Now remember that I can be 1 or 2 or 3, and ijk are cyclic. Now, from part 1, attention now, we derive, this is a long derivation, see? We derive that this mixed product is equal to the square root of G, where G is the determinant of Gij. Gij, a covariant, in this case, covariant component of the second order tensor. Thus, the volume element stays. That's the final over there. You see? dV is square root of G, dxi, dxj, dxk. Again, I is equal 1 to 3, ijk is cyclic. Now, I would like for you to pay attention on this observation. Why do we work with the metric? You see, the answer is when you develop the interior geometry, you see, not extrinsic but intrinsic geometry, okay, on 4D and also on 3D, okay, we just will use G. You see, in this exterior algebra or intrinsic geometry, there is no vector, no cross product, no dot product, as we are going to see later. Okay, I can derive relations using the intrinsic geometry also for the three-dimensional. Okay, but in the 4 dimensions, the only way to treat, you see, the elements, surface, area, and the whole thing is using intrinsic geometry. Okay, so intrinsic geometry can be applicable to the R3 and R4. but in R4, only intrinsic geometry. So G is Gij. It's very, very, very crucial for the intrinsic geometry. See, that's why we move always writing arc length element, surface area element, and volume element in terms of Gij. Okay, that's an important consideration for you.